Okay, just as a recap, can we have a go, first of all, if I write this one down and I'll press the button so you can see what I've written down. 6 over 7 minus root 8. What would the question be, do you think? If that was the part of the question, what do you think the question would be? Emily? Yeah, if you've got a surd on the bottom, it would be rationalise the denominator. I'll try and sort this focusing out a minute. Okay, so 6, 7 and 8 in there. What would my first step be, Catherine? Seven plus root 8 over 7 plus root 8, yeah. That's right. How would you go about, James, doing this bit here times that bit there?
That equals, well, no, it doesn't actually, that's wrong. You do the grid method.
Yeah, I would recommend you do the grid method. Can anybody tell me what will happen, what's guaranteed to happen in the grid method? Yep.
The root 8s will cancel each other out.
Yeah, the sort of top right bit and bottom left bit, they will cancel each other out. That's right, okay. Not going to do any more on that one right now. You can finish that one off yourself if you want to. If we had this one here, 3 over 7 root 5, what would you do if you were asked to simplify this one or rationalise this one? I am going to ask Conrad if he has any idea.
Would you times both sides by just root 5?
Yeah, just root 5. There's no need to times by the 7 as well. That's right, okay, that's how you would do that one. If you were asked to simplify root 72, anybody offer how we could start simplifying that one? What sort of thing are we trying to do? Well, someone who hasn't said anything. Yeah.
Find factors of it.
Okay, and what sort of factors am I looking for in particular?
Square numbers.
Yeah, can you think of one?
36.
36 times by 2. Okay, that would be a good move. So that's the square root of 36 times by the square root of 2, in other words 6 root 2. Okay. Here's one taken from the book I've made a note of that people didn't like last year, or whenever it was. So the question said simplify that. Now we've got cube root in here as well. Anybody offer any strategies? Because we haven't done one quite like this yet. Anyone offer any strategies for how we would start this question? Yep.
Would you have to deal with the indices? Like, you would have to maybe convert it so it turns from a square root to a cube root or something.
Okay, well, yeah, at the moment, if we look at this bit here, I've got a 2 with a 3 there. So at the moment, that is a cube root. Okay. How else can you write a cube root down without doing the root sign and the 3? Do you want to say? I can go to somebody else if you want, I don't mind. Go on, James.
Would it be root 2 divided by root 2?
Anything divided by itself would be
exactly.
1.
Well, no.
If I heard you correct. If you said root 2 over root 2.
Basically, yeah.
So I'm going to say basically no. Okay?
Shut up.
Right. How can I write this? If I want to do 2 and put a power up there, what power will it be for a cube root? Third. Yeah, a third for a cube root. Okay? So, over here, I could rewrite that bit as 2 to the power of a third. I've still got this other 2 here. They are being multiplied together, and it's all to the power of 6. This power of 6, it applies to both bits. It applies to the 2, so you can split this up as it's 2 to the power of 6, and I've got 2 to the power of a third to the power of 6, and they are being multiplied together. So that's a third there. Right, here I have a power to a power. If I have some number to a power, and then that's to another power, what's the sort of rule for dealing with powers to powers?
Times them.
Times them, yeah. So that's like a to the power of m times n. That's the rule we're sort of using over here from GCSE. Okay. So 2 to the power of a third to the power of a 6 is the same as 2 to the power of a third times by 6. And what's a third times by 6? 2. So that's 2 to the power 2. Over here I've got 2 to the power 6. I'm timesing them together. If you're timesing and the base numbers are the same, what do you do with the indices? Add them. So that would be 2 to the power of 8. Okay. Okay. Here's another one. Square root of 99 plus the square root of 44 plus the square root of 11, and the question says simplify. Yep.
They're all multiples of 11.
And that's a very useful thing to spot. Yeah, they're all multiples of 11. If you're thinking 11 is not a square number, that's not helpful, but actually it will be. Because, now I am going to try and ask somebody we haven't heard from yet, who I think is in the room.
We've got faces.
I do have your faces, yes.
Like year 9 faces.
Yes, they are. You're Gracie, but I think you said something. You said something. It's you four girls at the back who haven't really said very much so far. Is there a Charlotte back there somewhere? Is there? Yeah, Charlotte. Okay. How many 11s is this? Yeah. So that's 9 times by 11 square rooted. This one? 4 lots of 11s square rooted. And this one? 1 lot of 11 square rooted. And we are adding. So, what we were doing last time, as long as you are multiplying or dividing, we can split that up. It's root 9 times root 11 plus root 4 times root 11 plus root 1 times by root 11. You may decide to miss that line out and go straight to the next line. So, nearly forgotten who I asked already then. Charlotte. Right, square root of 9. 3, so that's 3 lots of root 11. Square root of 4. So 2 lots of root 11, and over there, 1 more root 11. Add those up. What's 3 somethings plus 2 of the same thing plus another one of the same thing? 6, yeah. So 6 lots of root 11. Okay?
It's simpler than I thought it would be.
Yeah, okay.
Surds is just like
I like Surds. Surds are just numbers. They just nice. Right, here's another one. Okay, let's just label that one up as page 1 for later on.
And not all.
can't do it.
Then that technique won't work. Okay. Well, we'll keep. I'm not going to say answer that directly. We're just going to keep doing some more, and then we'll see and we'll experience other things. So here's one: root 2 times by root 8 times by root 27 apparently can be written as k lots of root 3, and we have to find out what k is. Okay. Right. Root 2. Can we do anything to root 2? No. Okay. So that's going to be root 2. Root 8.
2 root 2.
Yeah. If you can actually remember that root 8 is 2 root 2, that is a useful one to remember. We actually did that last lesson. That has come from, it's a square root of 4 times 2, the square root of 4 times the square root of 2, so it's 2 root 2. That's a useful one to remember. Okay, 27, 3 root 3, because that's 9 times by 3, so that's 3 root 3, and we are timesing together. Okay, what is root 2 times root 2? 2. Okay, those come from the red underlined bits. There's another 2 here, that's being multiplied, and over here being multiplied by 3 lots of root 3. What is the answer to that underlined sum there?
12.
So I've got 12 lots of root 3, so I have found that k equals 12. Okay. You can get some sort of geometry questions as well, just to make sure you haven't forgotten too much. 6 for that length, 4 lots of root 6 for that length, x for that length. What topic is now involved from GCSE?
Right. No. Some
Pythagoras. So right angled triangles, no angles involved, Pythagoras. Okay.
I'm wrong. Yeah.
So using Pythagoras' theorem, I need to work out another girl over there who's not Charlotte, who's not Catherine, who's not Emily, who's not Olivia. Is there a Lucy over there? No. Not a Gracie. Is there an Olivia over there? That's you. Hello, Olivia. Right, Olivia. Can you tell me something that will work here using Pythagoras' theorem? A squared plus b squared equals c squared. Where does the c have to go? Which side? The hypotenuse. Fine. Okay, so can you use that on here? What can I write down?
So x squared
Yeah,
plus 6 squared
yeah,
equals 4 root 6 squared.
yeah, 4 root 6, all squared. Yep, okay, that's right. If we square 4 root 6, it's the 4 being squared, and it's the root 6 being squared. Okay, 4 squared is 16. Root 6 squared? Yeah, it's 6. 16 times by 6? 96. Some people are on the ball. So you've got 96 there. X squared plus 36 is 96. What's x going to be? Anyone? Sorry? Root 60. Yeah, that's right. If you take 36 away from both sides, you'll get x squared is 60. So x equals root 60. Can we simplify root 60? Is there a square number that goes into 60?
4.
4. How many times?
15.
Okay, so it's root 4 times 15. It's root 4 times root 15. Final answer? 2 root 15. Okay. Right, I'm just going to stop the video at that point.